Okay, introduction to series circuits. I've drawn a series circuit, the same series circuit two ways to illustrate something here. Series circuits are often called linear networks. Linear networks. And all that means linear is, well, there's essentially one path for current to flow. So the current flows up like this and then back to source. Take a look at the power supply that I've drawn here. And my power supply, I got a long line. This here is the symbol for DC power supply, often drawn like this. And the purpose of the long line is to denote the positive terminal, and the negative terminal is the short line. So I got a positive terminal and negative terminal. And all this drawing is over here is this drawing, but I've taken this and I've just stretched it out so now it looks like this. I mean, I could take this and bend it around there and it would look like this. So a linear network, a series circuit, is just one in which there is only one path for current to flow. So if we take a look at this circuit here and we go, okay, well, I've got two resistance values in this circuit. And what I want to do is go, okay, well, what is my total resistance in the circuit? And in a series circuit, the total resistance is the sum of the total resistors in series. It's just the sum. So if I have two series resistors, they're 10 ohms each, then my total resistance must equal 20 ohms. 10 ohms plus 10 ohms is 20 ohms. And these are called the Ohm's law triangle. This is the Ohm's law triangle. And this one here is called the Watt's law triangle. And we use Watt's law triangle for calculating power. So if we take a look at this, we always use E for voltage. We use I for amperage. Amperage was always used in the old days for amperage to denote intensity of circuit. So, and then R is for resistance. So going forward with your electrical careers, you will continue to use E instead of V. You will use I instead of A, and you will use R for resistance. P for power, and power is measured in watts. E is voltage measured in volts. I is amperage, and that is measured in amps. And R is resistance, and it's measured in ohms. So we have a total resistance of 20 ohms. And what this triangle tells us is that it's a way of understanding what the algebraic formula works for these. So, for example, if I know amperage and I know resistance, then all I do is I could say, well, I cover E up with my thumb, and I know that E is I times R. Let's say I want to know amperage. Well, amperage would be E over R. And let's say I wanted to know resistance. Resistance would be E over I. So again, E would equal I times R. I would equal E over R, voltage over resistance. And resistance would equal E over I, voltage over amperage. Over here, we say, okay, well, power in watts is equal to voltage times amperage. Voltage, E, is equal to power over amperage. And amperage is equal to power over voltage. So we can, by putting them into these triangles, we can very easily transpose this to be able to get our three values for Ohm's law and our three values for Watt's law. So let's take a look at this circuit here. We've got 10 volts and 20 amps. What I want you to do is perhaps stop the video and calculate what your total current in the circuit would be. So if you've stopped the video and you've calculated your total circuit, your IT, your total amperage in the circuit, according to this, your total amperage is equal to your voltage over your resistance. So I have 10 volts over a resistance of 20 ohms. That's going to give me 0.5 of an amp. And I want to list that. I want to show that in milliamps, and milliamps would just be times 1,000. So I would get 500 milliamps would be my value. So my IT would equal 500 milliamps. In other words, I've got this current that's flowing through this circuit here, and that current going through resistor 2 is going to be equal to 500 milliamps. And look, there's only one path for that current to flow, so all that current must flow through here. So the amperage through resistor 1 must equal the same, 500 milliamps, or half of an amp. And then, of course, it flows back to source. Now, if we look at the voltage here, we've got 10 volts here. We know that voltage is equal to amperage times resistance. So we would be able to say here, well, what about my voltage at 1? How much voltage would be dropped across this? Because really a series circuit is a voltage dividing circuit. A parallel circuit is a current dividing circuit. So when we're talking about series circuits, we're talking about dividing voltage. Current remains the same, remember, because there's only one path for current to flow. So it has to remain the same, but the voltages will divide. So series or linear networks are called voltage dividing networks. So we could determine what my voltage across one is equal to. We know that my voltage is going to be equal to my amperage times my resistance. So E1 equals my I1 times my R1. So I've got 500 milliamps, but I have to convert that back to standard unit. So 0.5 of an amp times my resistance of 10 ohms is going to give me 5 volts. And if I do the same thing over here, I've got the same values. My voltage across 2 equals my amperage across, through 2 times my resistance of 2. Then I would get the same thing, 5 volts. So the one thing you have to understand about series circuits is that the sum of the individual voltage drops, the sum of these voltage drops must equal the total voltage applied, 10 volts. If I had 3 resistors, those resistors would all have a voltage drop across them, and they would all sum to equal the total voltage in the circuit. Now, the only reason that this is 5 and this is 5 here is because, well, the value of the resistance is 10, the value of the resistance is 10. They're the same. The resistance values are the same. The current in a series network is the same, so the voltage drops must be equal. So in a linear network, the sum of the voltage drops equals the total voltage applied.